Good afternoon, RubyConf. Really excited to be here to talk to all of you today. Before I get started though, quick poll, show of hands. How many of you have heard of a disease called age-related macular degeneration, or AMD? Wow, that's a lot more than I expected. Okay, so great. You go on and do the talk for me if you like. Quick little word about Macuject. We're a MedTech startup based out of Melbourne, and our vision is to end preventable blindness because good vision is a human right. We're a fully remote company. We've got folks in Queensland, in New South Wales, in the ACT, in Victoria, even Tasmania. So we have another couple of states and territories to go to get Australian bingo. Our technical team, as the intro said, absolutely loves Ruby and Ruby on Rails. It makes our eyes happy. But what doesn't make our eyes happy is that almost 1 in 8 people, which is about 20 million Americans and about 200 million people globally, have a form of age-related macular degeneration. And it often goes undertreated. And so what Macuject is working to do is to address this shortfall in treatment ability and through a combination of AI, data and clinical expertise, help more people live better lives with this condition. And so we've got a talk this afternoon in 2 halves. Bianca is going to be talking about some really interesting Hotwire stuff that we've been doing at Macuject over the last 12 months, which left me with absolutely nothing technical to talk about at all. So I thought, why not come here and talk to you all about some of the things I've learned in the last 3 years at Macuject about the biology of the eye and some of the diseases we treat. Because honestly, what could go wrong about coming to a public forum like this and talking about something that you're not an expert in? And so before I joined Macuject 3 years ago, I really hadn't given much consideration to the eye or how it worked or all the pieces of it at all. And it turns out it's really, really interesting. Most of us have heard of things like the cornea and the pupil and the lens, but it goes so much further than that. And so there's 3 parts of the eye that I was wanting to point out this afternoon for you, which really links into the work that we're doing. And the first one of those is the vitreous humor. And let's just see if I can make this. Here we go. So the vitreous humor is this region here. It's kind of what gives the shape of the eye. And it's kind of a gelatinous-like glob or globe, if you like. And it's made of water, collagen, glycosaminoglycans, electrolytes, and proteins. And it's completely transparent. Now, the reason I mention this specifically is it's going to come up later in a slide, so really do remember the vitreous humor. The second part is the retina. And the retina is the innermost layer of cells within your actual eye. And so when light comes in through the cornea, down through the pupil and through the lens, it's going to hit somewhere here on the back of the retina. And you have to imagine this is 3D, so it's going to be all around the back of your retina. Once it does that, hits the outer cells of the of the retina, it's then going to travel through all of these transparent layers as well. And the most important part of this for the talk this afternoon is this concept of photoreceptors. And you have 2 types of photoreceptors in your eye. The first one is the rods, and the rods are about 120 million of those in each eye. And they're responsible for your nighttime vision and your peripheral vision. The other type are cones, and you can see they're in red, green, and blue. So no surprises, they help you see colours, but they're also critical for how well you actually see, so what's known as visual acuity. As light's coming in, here we go. As light's coming down through these cells, these are all neural cells, we'll come back to that in a minute, it hits the rods and cones and the photoreceptors, and a process called transduction occurs. Transduction effectively translates photons from the light into electrical signals. Those electrical signals then start traveling back up through this pathway, again, all neural cells, All these cells themselves are super important, but I haven't got time to get into them all this afternoon. And eventually, they find their way into the optic nerve. And so from there, those electrical signals are going back to the brain. The brain and the eye work together to end up giving you vision, and that process is super complex. It's well worth a deep dive on Wikipedia if you have the time one night. And the third part I wanted to highlight this afternoon is the macula, which is this little part down here. That's about 5 millimeters across. The macula is the central part of your retina, and it's really important for your vision. The part of the retina which makes up your central vision when you're directly looking at objects, such as when you're writing really cool Ruby code, or reading a book, or looking at some guy on stage pretending he knows what the eye is actually all about. Within the retina, the very core part, within the macula, the very central part here, this little dip, is known as the fovea. And the fovea is where you have the maximum concentration of cones. And you remember earlier, cones are what help you see colours, and they're critical for your actual vision. Damage in this part of the macula, within the macula and in the fovea in particular, is really, really critical for bad sight. So diseases in this whole macular region are really what most people with AMD, they have disease in this particular area. No prizes for guessing that the Macuject macular is a combination. And later in the slides, you'll probably be able to really easily figure out what the ject part is. So age-related macular degeneration. I mentioned it earlier, so I'll talk way more if you knew what it was, so I'm actually surprised by that. But for those that don't, it's a medical condition which results in blurred vision in the center of the visual field. So it's damage within that macular area. And so for someone that doesn't have this disease, this photo here on the, right-hand side is what we would normally see. And someone with AMD, with a loss of central vision, is going to see the world like this. So they have blurriness in the central vision component, and they can't recognize faces or drive or really undertake any day-to-day tasks very easily at all. It's really not a good disease. Eventually, this is just going to get worse and worse and worse, and that blurriness is going to go all the way out to the edge of the photo. AMD, for most patients, starts in around your 50s, and it will slowly increase in severity until your 70s, until it comes to a form called advanced macular degeneration. There's two forms of advanced macular degeneration. The first form is geographic atrophy, where cells are actually dying in that macular part, so that's what the atrophy means. And there's a wet AMD version, which is where abnormal blood cells are growing from around that macular area, and they're leaking fluid into the vitreous humour. So that's the wet version. Risk factors for AMD, clearly age is one, poor diet is another. If you have a family history of AMD, you're 27 times more likely than the average person to also get this. There's a strong link there. And if you're a smoker, you're 4 times more likely than an average person to get AMD. So if you have a family history of this and you're a smoker, you're actually 100 times more likely to end up being diagnosed with AMD. These factors are multiplicative. How can you reduce your risk? Oily fish at least 3 times a week. Salmon, sardines, trout, fresh, frozen, whichever way you like to eat it. Green leafy vegetables, if you're cooking it, you need to have about a cup once it's cooked, which is quite a bit, but that's the amount you need to get the good vitamins. Bright yellow or coloured vegetables, such as sweet potato, and cook with olive oil, butter, ghee, or coconut oil. There's only treatment for AMD, and the treatments are different for wet and GA. There is no cure. So once you're diagnosed with this, your treatment's going to be ongoing for the rest of your life. And so how do you treat AMD? How do you treat a disease of the eye? And it's medication delivery via intravitreal injection. And what's that? That's this. Got your attention? Wait, there's more. So it's an injection directly into the eye. You remember earlier I talked about the vitreous humour, our friend here, if I can get this pointer to work, this whole area of your eye. You can see the medication's being delivered into that part, and from there it's being able to be absorbed by the eye and treat the conditions. What I wanted to do is actually also bring a photo of the treatment of this in real life. But I totally understand that some of you probably aren't going to want to see this, so if you don't want to, no, no problem, you can turn around now. You've got about 3 seconds once I press this button, and this picture is going to come up. And so here it is. This is our CEO and co-founder, Devinder Chauhan, undertaking the injection. Devinder is a retinal specialist, an ophthalmologist, a retinal surgeon. He has about 25 years experience in this field. He's a very, very intelligent man. Taking the photo is Yang Do, who is an ophthalmologist and has worked with Devinder for about the last 12 years. And they now both work at Macuject on helping us build the technology that goes inside the product. We also have another ophthalmologist that works on the team, Steph Major, who also trained with Devinder for about 12 years. So we're really lucky to have really, really talented people. In the photo, you can see they're using an eye speculum that's keeping the eyelids open so that the treatment can be delivered safely. And if anyone is concerned about, you probably can't see it with the words over top, but there's some orange down there. That's not blood. That is disinfectant that's put on before this occurs. There's no pain involved with this. Before this occurs, there's drops that are put into the eye and other treatments that numb everything. There is discomfort and there is some pressure. I've been in the clinic when these are being done. You would be absolutely shocked at how quickly this is actually over. It really is over that quick for these injections. It's not fun. You don't want it. Most people get really scared when they see this picture because they have in their head this vision of a needle coming straight at their eye like that. That's what most people think when they first get diagnosed. It's not like that at all. If you imagine while you're sitting there now, put your head back slightly and look towards the ceiling, and then bring your finger from the side like this, and you'll see you won't even notice the finger is coming towards your eye. So there's really nothing to be scared about. It's not the terrifying, horrible movie that people see where a needle comes directly at you. And so I said before there's only treatment, there's no cure, but what is the standard treatment protocol? And that is every 4 weeks, once diagnosed, for the rest of your life. You can imagine a needle once every 4 weeks, once you're diagnosed, for the rest of your life is not a very comfortable thing to have to deal with. If you have it in both of your eyes, that's 2 needles. If you have GA and wet AMD, it could be up to 4. With Macuject, we've been putting our software into clinics here in Australia. We're now starting to move into trials in the US, and we've got a long way to go on this. But we're able to get these injections out to between 6 to 10 weeks for patients, and in some patients even longer. We have patients on the platform who have had over 100 injections in a single eye. And so you can imagine for them, this extension, any extension, is a massive quality of life improvement. It's also really, really important for the doctors. There is not enough doctors who are skilled in this to be able to treat these patients. So the longer these periods are, the more availability the doctors have, the more patients they can see and treat, the less people are going to go blind. It goes on and on. So this is really interesting, but why talk about it at a Ruby conference? And really, it was a chance for me to pivot to a topic that I'm quite passionate about, and that's problem domain knowledge. It's a critical factor in developing software, but it's often overlooked by a lot of people. When you have problem domain knowledge within your technical team, you're able to create solutions that work well within the context that they're designed for us, medicine, for all of you, whatever it is you're working on day to day. At Macuject, we practice this approach to great success. The entire presentation up until now is a testament to the fact that our technical team works very closely with our medical experts. And likewise, our medical experts are working very closely with us to learn about the technical environment. So they're learning about things like software development, cycles, cloud, our machine learning processes, and for one particular poor soul, the Jira query language. Benefits of problem domain knowledge, all the things on the screen here, better communication, user-centered design, efficient problem solving. One really interesting example of this is when you build something for an ophthalmologist, the left hand is shown on the right side of the screen and the right eye is shown on the left-hand side of the screen because that's how they're looking at a patient. So things like that become really, really important, and you'll have the same things in your domain. Ultimately, all leading back to innovation. So if you take one thing from my talk today, I hope it's probably going to be the photo of a needle going to someone's eye. Let's make it, it's what's going to happen. But also, please think about the problem domain in which you're working. Reach out to your colleagues, learn about their specialities, teach them about the specialities that you are an expert in, and gain all these benefits of this problem domain knowledge sharing. And so, I'm the pest at Macuject that likes to share a lot of horrible dad jokes in our Slack channel. And of course, a perfect way to segue over to Bianca's side of the presentation is to share one of those with you. Did you hear about the website for people that suffer with eye pain? It's a site for sore eyes.
You know what's a real sight for sore Rails dev eyes? Hotwire. And with that seamless transition, let's talk about Hotwire. So Hotwire, or HTML over the wire, brings together Turbo and Stimulus to present us with a collection of techniques for developing modern web applications. It aims to give us a simpler, more productive development experience without sacrificing any of the speed or responsiveness that we've come to expect from modern web applications. Let's talk a little bit more about what Turbo and Stimulus actually give us. So Turbo is made up of multiple parts. There's Turbo Drive, which is really the latest iteration of Turbo Links. It gives us accelerated page changes and form submissions. It's what allows our Rails applications to feel like modern web applications when we're navigating around within them. Turbo Frames allow us to break down complex pages into multiple independent contexts within the same page. And that allows us to do some really powerful things, especially when we combine it with Turbo Streams. Turbo Streams give us the ability to stream partial page changes over WebSocket using a really easy to work with set of CRUD-like actions. One of the really good things about working with Turbo is that we can basically work on an application that just feels like a standard Rails application, but then by adding some additional HTML attributes, we're able to get basically the superpowers that Turbo gives us. Sometimes that's not going to get us all the way to what we want to achieve, and that's where Stimulus comes in. When we feel a need to write a little bit of custom JavaScript, we can hook into a Stimulus controller. Stimulus is a HTML-centric approach for adding a Goldilocks amount of JavaScript. It gives us a really nice way to add just the amount we need, just where we need it, no more, no less. When I joined Macuject in February of last year, our front end was primarily in React. So over the last year and a bit, we've been gradually migrating our front end from React to ERB templates and Hotwire. So what does that process look like for us? Well, it's really important that our web application continues to function exactly as is expected while we're making this transition. So we take it really slowly, one bit at a time. We'll first identify a particular page or component that's built in React, and we will look at it and not touch it. We will leave it alone, leave it to do its job. Alongside it, though, we'll build a new version using ERB templates, and if it needs some interactivity, we'll see if Turbo is the right solution there. If it is, we'll add Turbo. If not, or if it needs a little bit more of custom JavaScript brought in, then that's when we'll write and hook into a stimulus controller, that Goldilocks amount of JavaScript. We then take that new version to the clinical team for feedback, and it goes through user acceptance testing. We iterate on that as needed, and then only once we all agree that the new version is ready to replace the old version, then we will actually take away that React page and replace it with the new version that's been built with ERB templates and Hotwire. During this time, all our new features are also built using ERB templates and Hotwire. We don't build anything new in React during this time. In fact, in the year and a bit that I've worked at Macuject, the only times that I've touched the React code, other than a very minor bug fix, have been when we've gone through this process and it's time to actually remove some React code, which is a really nice feeling. So why is Hotwire a good solution for our team at Macuject? Well, we're a really small team. When I say small, other than Bradley and myself, we've got one other person working on the web application. And we're a team who is familiar with Rails. Hotwire gives us a very Rails-like way of working. It allows for rapid development and rapid prototyping, which works really well with our small team and our startup environment. Hotwire reduces, or in many cases actually eliminates, the need to write JavaScript for basic features. It removes the overhead of a front-end JavaScript framework. In our case, we're able to slowly remove React. And that leaves us with less code complexity and an equally good user experience. So that's a lot of talking. Let's look at some of how we've used Hotwire in Macuject's web app. Let me introduce you to the Today's Patient Visits page. For clinics who are making use of the Macuject platform, this is the main page that they're going to be working from throughout the day. So imagine a physical clinic, a patient walks in, the process is that the orthoptist will take that patient and get scans taken of their eyes. So once those scans have been taken of their eyes, the images from those scans will be automatically uploaded into Macuject's AI. The AI is going to do some processing on those images, and as soon as that processing is done, the moment that it's finished, it will communicate with the web application, which will set off a TurboStream broadcast, and as soon as that happens, the patient record is going to appear in the waiting room. And that will continue to happen throughout the day as more patients come in and get seen and their eyes are scanned, and the images are processed by the AI, and the AI is done processing, so it communicates with the web app and sets off the TurboStream broadcast. The patient record is added to the waiting room table. You get the idea. An important thing here to note is that anybody in the clinic might have this web page open, this particular page of the platform open, and they'll see those patient records move into the table in real time. They don't need to wait at all. As soon as it's ready, it moves into that table. They don't need to reload the page. They don't need to do any kind of yucky React polling stuff that might otherwise be needed. It all happens in real time thanks to Hotwire. So when the patient is ready to be seen by the doctor will click on the patient record in the waiting room table, which takes them to the patient treatment page. The doctor will then be able to use this to help inform what they're doing. The doctor will make decisions about the treatment and fill in information about the treatment given on that day. And then the doctor will click on complete treatment at that little blue button at the bottom there. The moment they click on that, the Today's Patient Visits page is again updated, and that patient record has moved from the waiting room table into the completed visits table. So again, anybody throughout the clinic who needs to know can have this page open. Maybe they're at the front desk or elsewhere in the clinic. They've got this page open. They see that record move from waiting room to completed visits in real time. They know the status of the patients whenever they need to. So let's look at some code and break down what's really happening here. So this page has 3 turbo frames on it. It's got the outer turbo frame and 2 inner turbo frames. Let's first talk about the outer turbo frame, and then we'll come and talk about the others. So the today's visits tables turbo frame is wrapping the central content within the page. The code that I'm showing here is a bit simplified. I've taken out all the CSS classes and some other bits that don't need to be there to be able to talk about Hotwire today, but this is effectively what the code looks like. The turbo stream that I mentioned that gets broadcast when a patient record needs to move in and out of one of or both of those tables is what you see on line 1 there. The turbo stream is scoped to an individual clinic. As you can imagine, Macuject is used across multiple clinics, and you only want patient records for the specific clinic to be shown on that page. So the turbo stream is there for the today's visits broadcast for the particular clinic. We then have the turbo frame tag for today's visits tables, which is what we saw on the previous slide. This is the turbo stream. So again, scopes to the clinic, so we're passing in what the clinic is. We've got the today's visits broadcast on line 16 is the name of the stream that we want to hook into. We're targeting the today's visits tables turbo frame. And so with turbo stream broadcast, there are 8 different actions that you can hook into to do different things. And in our case, because we're dealing with some query param logic and some other things, a simple update didn't quite give us what we needed, but it's Hotwire. It's not that hard to get a little bit more than the default. And so what we've done here is when that turbo stream is broadcast, it will prepend this little bit of HTML. What this HTML does is, as soon as it is prepended, as soon as it's added to the today's visits tables turbo frame, then it's going to connect to the reload stimulus controller, which you can see the connect method of that down below. That connect method is going to grab the URL, including the query parameters, and we can then use it, what we're doing there on line 16, to reload just the specified turbo frame. So we don't want to reload the entire page and whatever else might be on that page. We want to reload just the today's visits tables turbo frame, and that's what we're able to do with that turbo visit on line 16. So that's the frame that we just talked about. Let's talk now about those 2 inner turbo frames. And this is where being able to break down a single page into multiple independent contexts really becomes awesome. So what you can see here is the use of those turbo frames in action. So you can see somebody typing into, it's really a free text filter, but I'm just going to call it a search box. You can see somebody typing into the search box there, and it's filtering for records just for the specific table. So we're able to do that, and also what you're about to see now of being able to sort just the individual table. We're using query params. You can see that in the URL bar, but basically we're able to do this so easily and with quite a small amount of code because we can isolate the context of each table as its own turbo frame and work with it independently and update it independently. So this is the same code we showed before, but I'm just highlighting a different portion of it. You can see that we've got 2 different things. They're basically the same as each other, except they're targeting the 2 different tables that are on that page. So let's just talk through the waiting room version of that, the lines 7 to 12 there. So that table is wrapped in its own instance of data controller filter. So that's the filter stimulus controller that I referred to earlier. It's got its own instance of that. It's then got a partial that we'll look at in a moment, the free text filter partial, which we're telling we want to interact with the waiting room table. We've then got that turbo frame, which is what you saw wrapping the waiting room table. And within it is the actual table. So let's go into the free text filter partial and look at what's actually there. There's not a lot there. It's a pretty simple form, and it's got an input field. What makes it interesting and gives us the functionality, though, is the way that we're hooking into that filter stimulus controller. So we're hooking into the the filter stimulus controller, we're telling it the name of the turbo frame that we want to do something with on line 4 there. So if it's the waiting room table, it's going to be waiting room _ patient _ table. We're telling it the table name as well. The input field on lines 9 to 10, we are also saying that we have a data filter target of search input. Basically that means we're going to be able to, in our filter controller, refer to search input target as an easy way to refer to our input field. And this is the relevant parts of the filter stimulus controller. So that search input target that I just mentioned, on connect of the filter controller, which is going to happen twice on that page that we've been looking at, because it's going to have one instance of it on the waiting room table and one instance of it wrapping the completed visits table. But I'll talk about it for the waiting room table right now. It's going to connect and it's going to add an event listener to the search input target. So anytime that anybody starts putting keystrokes into that input field, it's going to execute the submit form function. We've got a timeout on that because you don't want to execute the function anytime somebody enters a single character. You want to allow, we've allowed 300 milliseconds for them to type a few characters in before it actually automatically starts doing that filtering. But then basically what's happening is line 24, we prevent the default form submission because we want to take over and do something else. Line 27, we get whatever it is that's been typed into that search input. Lines 30 to 32, we're basically creating a new URL object, constructing the query param, so in this case it would be waiting room _ search as the name of the query param. We're setting its value to whatever has been typed in to the input field, and then we're able to, on line 35, again we're able to do a turbo visit, so we're able to basically reload using that information that we've got from the input field. We're able to reload just that specific turbo frame. So in that case, if we're searching for something within the waiting room table, we're able to get the information for what's being searched for, and we're able to reload just the waiting room table. Similarly for the other table. Which brings us back to what you see here. Again, somebody's typing characters in, all that stuff I just talked about is happening, which allows this really seamless thing to happen, no page reloads, nothing like that, and we can operate on those independent contexts as needed. Hotwire allows us to develop highly functional and responsive user interfaces. And by bringing that together with our team's focus on problem domain knowledge, that's what's driving us towards our goal of ending preventable blindness. Thank you.